Hi everybody, so today we will continue to see one example on application of second order ordinary differential equations. Okay, so this is the application question involve second order ordinary differential equations. Okay, when you get this type of equation, the first thing you need to do is not to panic. Do not be panicked. Okay, you need to read carefully and analyze all the information given to you in the questions. Okay, let's read together. An RLC series circuit can be described by a linear second order differential equations given by L d square q dt square plus R dq dt plus 1 over cq equal to et. So this one is your second order differential equation that we will solve later. Okay, if we see in this second order differential equation, we have our differential equation in terms of dq dt, where q is our dependent variable and t is our independent variable. Therefore, other than q and t, we can consider it as a constant. Okay, in the equation, L is the inductance in henries. So henries is the unit for L. R is the resistance in ohms, and C is the capacitance in farad. Okay, and ET is the electromotive force in volts. So the farads, the ohms, volts, and henries is just a unit. Okay, note that QT is the charge in coulomb on the capacitor at time t, and IT equal to dq dt is the current in ampere at time t. Okay, so this one is just the information for you. Okay, the question is, suppose L equal to 1 Henry, R equal to 2 ohms, and C equal to 0.2 farad. Find the charge function QT if electromotive force ET equal to 2 cos 40 is applied. Okay, so if you see here, you are given a few information where your L is equal to 1 Henry, but Henry is just a unit, so you just need to consider 1. Okay, R is equal to 2 ohms. Ohm is the unit for R, so we consider the value of R is equal to 2. And C equal to 0.2 farad, and farad is a unit for C, therefore we consider the value of C is equal to 0.2. And given to you, ET is 2 cos 40. Okay, so what you need to do is you need to substitute all the value here into the equation that you have above here. Okay, so we have L times with this q d square q dt square, and we know now our L is equal to 1. So 1 times with d square q dt square, you will have d square q dt square. Okay, plus with R. R given to you in equation is equal to 2. Therefore, you just substitute 2 dq over dt plus 1 over C. So your C is 0.2. You just substitute 1 over 0.2 Q equal to ET, and given to you ET is equal to 2 cos 40. So 2 cos 40. So now, after you substitute all the information given to you in the equation, you already have the usual second order differential equation that you always see before when we learn about method to solve second order differential equation. So there is no problem at all to solve this application question as long as you know how to analyze the equation and how to get the information from the equation. Okay, so now we want to solve this second order differential equation since it's given to you to find the charge function Q. Okay, before this, we'll always use d square y dx square, right, in our differential equation. And when we have differential equation in terms of dy dx, what is our solution? Our solution we always have in terms of y equal to whatsoever, right? Now we have our differential equation in terms of q and t. Okay, therefore our solution must be q t equal to. So you need to know these things so that you will not panic when you have been asked to find qt. Okay, there is no problem. It's a solution of our differential equations. Okay, let's solve this one. Okay, we can use either undetermined coefficient or variation of parameter to solve the this non-homogeneous second order differential equations, but let's solve the homogeneous part first. Okay, so I can write this differential equation as d square q dt square plus 2dq over dt plus, okay, 1 over 0.2 you can find in the calculator. You will get 5 q equal to 0 because we want this to be homogeneous. Now we turn it into characteristic equations where you will have lambda square plus 2 lambda plus 5 equal to 0. Okay, so from here we get our value of A is equal to 1, our value of B is equal to 2, and our value of C is equal to 5. So now we want to check case for our characteristic equation. So B square minus 4AC equal to 2 square minus 4 times 1 times 5. Okay, so you have 4 minus 20. Therefore, you will have negative 16, where negative 16 is less than 0. So when we have the b square minus 4ac less than 0, means that our quadratic equation now, or our homogeneous equation, has the solution in case 3, where case 3 involve the complex root. Okay, therefore to factorize the complex root, you need to use a quadratic formula. Okay, so we have negative b plus minus square root of b square minus 4ac divided by 2a. So negative, our b here is 2 plus minus square root negative 16 divided by 2 times a is equal to 1. So what you will have here is negative 2 plus minus square root 16i over with 2. So you will have negative 2 plus minus 4i over with 2. And simplify this fraction, you will have negative 1 plus minus 2i. So now you already have your lambda in terms of alpha and beta. So you know that your alpha is equal to negative 1 and your beta is equal to 2. Okay, so we will have our yc equal to exponent alpha t. So exponent t times with a sine beta t. So a sine 2t plus with b cos 2t. So now this one is our yc.